And now to prove that something is positive, there really are more or less only two options. One option is to complete the square, and then you know you're looking at a positive quantity. The other option is to show that the quantity you are looking at is a sum of terms that you can individually prove are positive. Now, looking at this form, I'm not really feeling any kind of complete the square. So we're going to try to do this by producing terms that we know are only positive. So one opportunity we have, and it's kind of given away here, is that I know E naught is the lowest possible energy. So if I were to write this and compare these E's to E naught, then I know that these terms here are always greater than 0 if n is greater than 0. For any other state but the one unique ground state, right, the energies would be higher, and this would be positive. And it actually equals 0, of course, if n equals 0. So this, I know, is going to be a positive number. These guys, these probabilities, I also know are always going to be at least equal to 0, because probabilities are never negative. So this looks great. This looks like I can prove that this thing here is always going to be some kind of a number that will never be negative, at least. Now, of course, as soon as I subtracted off my E naught, I messed up my expression. I better restore my expression, but that's easy enough. I can add back the piece I had taken out, sum of the Pn times E zeros. And nicely, you will notice, E0 is a constant, so I can pull it out of my sum. And finally, we know, of course, always the sum of the probabilities has to equal 1. So this term, whatever it is, gets added to E naught. And that's what I'm looking at. And the beauty is I want to compare this to E naught. Now, looking at what I know from these terms, you can see that these terms here are always at least 0 or might be 0, and they're multiplied by other terms that are always 0 or at least 0. The point is that every single one of these terms is definitely going to be greater than or equal to 0, so therefore the first thing we can conclude is that this result then must be at least as much, because these are at least 0, must be at least as much as E0. And that's the first half of what we wanted to prove, right? That it's at least always greater than E0. I next made a claim that it would be equal, right, only if psi is something times the ground state, right? Psi is essentially the ground state. Now, for this to give equality, right, so for equality, right, what we need is that every single term here, which could be 0 or could be greater than 0, they must all be 0. We need all the terms here to be 0, because if any one of these terms is not giving me 0, I will get something that's greater than E naught. So we need 0 to equal the P of n times En minus E0 for all n. Now, of course, for something to be 0, we need either or both of the other two pieces to be 0. Now, the first thing to notice is that for n greater than 0, I already mentioned that this term is not 0, so then the probability would have to be 0. So that implies that for n greater than 0, Pn must equal 0. Well, that tells me then that Pn must equal 0. That tells me then that there is no probability, right, of finding the particle, right, in any state that has an energy greater than E0. These weights, for example, in the quantum principle of superposition, right, their square gives me these Pn's. So therefore, I see that the weights for all the n's greater than 0 must equal 0. And so then, therefore, if I write down my my state psi of x for this situation of the equality that I'm considering, for equality, psi of x by quantum principle superposition is a sum over all states, their weights times the corresponding states. This sum, of course, has two different types of terms. Either n is 0 or n is not 0. When n is 0, I get W0 times phi 0 of x. And then for the terms where n is greater than 0, as I've just shown, all of those weights must be zeros. And so when I want equality, I must have just some multiple of the ground state, and that completes the proof. We've completed the proof of both the inequality and the equality, and that then deserves the happy professor symbol. Very good. So we will pick this discussion up later on.